Okay, question 11 is a homework problem, which means you're at home and you may or may not have a TI-84 calculator. So I'm going to choose to do this problem using Desmos. Although a lot of you do have your TI-84 calculators, and because you have those and because they're allowed on the SAT, and they're all allowed on a lot of AP tests, AP Calc and AP Stats. I don't know how you would take the AP Stats test without one of these calculators. It's really a good investment to have one of these and get proficient at using it, especially the color ones. But for this problem, because you're at home and I know not all of my students have this, we're going to use Desmos to do this problem. So let's go ahead and review how we would enter this data and look at it in Desmos. So the Battle Creek Bakery makes bread in large batches. Yeast is added to the bread dough to create carbon dioxide gas bubbles in the dough. These tiny gas bubbles give the bread its light texture. They also make the dough increase in size over time, a process called rising. So I'm sure a lot of you have parents, maybe you've helped out mom and dad make bread like this. And when you get that, you think you have to activate the yeast by maybe, do you put it in warm water or something? But you've seen this and you've seen the bread rise, even pizza dough, and then maybe you punch it down before you bake it. I don't think you punch down bread dough, though, before you bake it. Anyways, you can see we've got here some data, and we're just going to go ahead and say that x is my independent variable. It's the rising time, amount of time the bread has been rising. And then this is volume of the batches in cubic inches. These are y. And it's not the same batch. It says it's data is collected from 6 batches of dough. So there are 6 different batches, but they did choose to record the volume of the dough at different time intervals. So the first time is 34, etc. So we're going to go ahead and use our friend Desmos. So here's Desmos, and you guys do have accounts already set up for you. I'm going to go ahead and sign in real quick, and I'll use my school district account. So you can see here I go. And the other thing I want to do is I'm going to go ahead and save this file. So I'm going to hit, it's untitled, but I want to call this, well, this is problem, what is it? Problem, chapter 9, problem 11. And I'll call this Battle Creek Bakery. That should work nice for me. So I'll save that. And it's so nice because now I have a kind of a more permanent record of this Battle Creek Bakery. If I wanted to, I could click that and rename it. That's just fabulous. I could even duplicate it and have another copy. So the first thing I want to do is I want to enter a table of values here. So you're just going to click Add Item. We're going to add a table. And we're going to enter our X values. The first X was 34. And then I've got 150. It was 218. 325, 357, and I think the last value was 471. 34, 150, 218, 325, 357, and 471. So, that's just me double checking. This table, by the way, is in your online book. So if you want to open it up and do it yourself, you can. In fact, I encourage you to not just watch this, but be good at doing this. It's a fun thing to do. I enjoy doing this, and I think you could follow these steps along too. So now let's enter our Y values. So our Y values at 34 minutes for that first batch was 21. And then we went to 198. Then we went to 283, 467, 980. And the last value there is 2743. And I just like to check them. So there we go. We've got X1 and we've got Y1. And the first thing we notice is like, I can't see any of these points, right? That's because my domain and my range on this graph window I'm looking at aren't really set up to see this well. So if you bring your cursor over to the X-axis and hold down the Shift key, you can see the icon changes to this little arrow. Now if I click, I can drag this down and shrink it. And probably I want to get X to be about 470. I need to be about 470. There's 150. So that should be adequate, right? So I can see X is from 0 up to 4, almost 500. I need to do the same thing with my Y values, and you can see the first value I'll see is right there where Y was 21. Then next I should see when it was y was about 200. There it is. And then I should see the 283. And then I'll just bring this down. I need to bring this down pretty far so that I can see all the way up to 2,700. So, okay, so I do see the 2,700, but this toolbar is in the way, so I'm going to make this just a little bit shorter. So there I can see that point up there. So I can now see my values. And what we're asked to do, and I can look at those points and say, I don't think this is going to go well. I don't think this is the best idea. But it says, use your calculator to determine the equation of the least square regression line, and then also to sketch the scatter plot. So we'll do that. Let's go ahead and, we're not going to use our calculator, right? We're going to use Desmos. So we're going to go back over here. And I want to now come up with the line that fits this data. So if you want to do linear regression in Desmos, it's pretty straightforward. We're just going to say, we're trying to connect y1s to x, y to x, want to create a function between them. So we just say y and then type a 1, and it immediately became a subscript like that, right? So when I just do y1, it knows that I'm now talking about the 6 elements, 1, 2, 3, 4, 5, 6 in this table. And I'm going to say y1, and then you hit tilde. So it's shift, and it's the button right below the escape key on my keyboard, and it looks like that. So y1 tilde, and then we're going to say mx plus b. So m, and then I'm going to do x1, right? I don't want to do x, I want to do x1, and then plus b, and enter. There we go. y1 equals mx plus b, and you can see it's added this line of best fit. This is a least square regression line, and it's come up with my 2 parameters here. I can see m, and I can also see b. So what I want to first of all do is I'm going to grab this graph and I'm going to put it in my work. So there's a share button here. I'm going to hit share graph, and I'm going to export this image. And this is perfect, right? So I'm just going to come in here. I'm going to make the lines medium so I can see it really well. My zoom is set to 100%. So if I right click this, I can just say copy that image. And then I can come back to my notebook in OneNote, and I'll just right click and I'll say I want to paste that image. So there is my line with my my line of best fit, my least square regression line. What I want to do now is it says determine the least square regression line. I should write that down. I didn't write it down. So let's go back and look at Desmos. It says that, oops, I don't need this anymore. It says that M is about 5.4, right? 5.4, and B is negative 218 negative 628.0. Negative 628.0. So let's see if I bring this down here, I might be able to see this and remember it better. Oh yeah, I can see that. You can't see it, but I can see it. So I'm going to write down y is equal to, M was about 5.4x, and then minus 628.0. And I do include the 0.0 there so that I can see that I am rounding to the nearest tenth, right? So both my slope parameter 5.4 and my y-intercept parameter 628.0 are rounded to the nearest tenth. The next thing I'm asked to do is it says sketch the residual plot and interpret it. Oh, we're in for a treat. That's going to be pretty straightforward here. So let's bring this back up here, and I want to create the residual plot. And you can see when you do a linear regression in Desmos that it sets it up right here. It just says residuals plot. So I'm just going to hit this button, and then almost automatically out of nowhere, I got these values. Now I don't like, I can turn them off and on. I don't like that it's red. So I'm going to come in here. I want to change this color. Oh, I can change the color. I can change the symbols. Oh, I'm going to make them X's, and I'm going to make them orange, blue, orange. I don't know. Oh, lines. What? I don't understand that. I don't want that. I don't want that. So, okay, so there we go. So let me, oh, what? Please Control Z. Oh, thank you. Okay, so now we can see our residuals here, and as I look at them, I can tell right now I am not happy with the linear model for this data, because if I let me turn off the scatter plot and let me turn off the line of best fit. So I'm just looking at the residual plot right now, and you can see for this residual plot, it's clearly doing this high, 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 low, and then back up high again. So I see this just this single swoosh like that, this pattern that's indicating. And there may be more points that it's happening, but when you see this, your data is, you've got positive residuals and then negative and then positive, or it could be the other way. You could have negative residuals to positive to negative. That's a great indicator that your line of best fit is not going to be aligned. So let me go ahead and grab this. This is the residual plot. So I'm just going to go ahead and grab a copy of that and share it. So export the image. There's my residual plot. And I'm going to copy that image. And then let's paste the residual plot into our notebook also. So I'll just Control V that. So here's my residual plot. And it's really clear to me that from this residual plot, I probably do not want to have a linear model. Let me bring this up to, I think I'd like this here better. So it says, sketch the residual plot and interpret it. Okay, so let's create an interpretation of the residual plot, and maybe I can type it right here. Can I type there? Maybe if I click with my mouse. Let's see, draw. No, it's not letting me type anything. It's interesting. Can I move this around? I'll just type it right here. I'll say the pattern and the residual plot indicates that a linear model EL may not be a good fit. And it's just because I see this pattern in the residuals, right? I mean, if I was to go back and look at the correlation coefficient, I think it was 0.87. So it's got a pretty strong correlation, but it's a super small data set too, so that doesn't mean much. But definitely the pattern in the residual plot indicates that a linear model may not be a good fit. So let's move on. The next thing we're asked to do is it says, since the equation involves increasing growth over time, try fitting an exponential model to your data. What is the equation of the exponential model that fits the data? Oh, hey, we get to go back to Desmos. So back at Desmos again, we can see our data points, our original data points. I'm going to go ahead and turn off the residual plot. There's that line, right? There's my linear model. So now what we're going to do is we're going to come up with a different model. We're going to come up with an exponential model. So to do that, I've just, there we go. To do that, what I need to do is what are you doing? Leave me alone. I'm going to come down here and I'm going to add something else, right? So this time we did a linear model. Now we're going to do a very similar thing, except instead of doing mx plus b, we're going to do the y1. So y1, tilde, and I'm just going to type a, b, raised to the x. Now, I can't leave it at x. It has to be x sub 1, right? Oh, this is fabulous. Look at this. So y equals ab to the x. It created this model for me. So you can see my 0th term is 25.1879. And my multiplier, oh, that's a very small multiplier. It's 1.01. Tiny little CO2 bubbles, carbon dioxide, right? So this is a model, and I could just tell right now, much better fit. I think the problem said make a residual plot for the, it asked me what's the equation for the exponential model. So let's write that down. So those are very, I'm going to have to round those numbers to the nearest hundreds, Because if I rounded it to the nearest tenth, look at what b would be. B would be 1.0. And if your multiplier is 1, you're never going to have any growth at all. So let's round this to the nearest tenth. So we're going to say, what is the equation of the, so this equation here is y is equal to a, which is 25.2, if I round to the nearest tenth, 25.2, times b, which is 1.01, rounded to the nearest tenth, raised to the x power. So there's an exponential model for the data. And then finally, make a residual plot for the exponential model and interpret it. Oh, this residual plot, it's going to be so much better than the last one, I can tell already. And you can see right here, you can say, oh, let's just go and click it. There is the residual plot. It's unfortunate that those dots are green. Why did they do that to me? Let me come up here and say, look, I don't want those to be green. Let me make them, oh, it won't let me do that. I'm going to slide this over. Now I can say I want to change this to blue, and I'll make them little X's again. I like the X's. So I'm going to say I'm done with that, and I'm going to come back over here and okay, there we go. So we can see our residual plot, and just much better. This is pretty much the same scale that we looked at the other one, but notice how these points are really hugging the x-axis, and you can see it's like it's up and then down and then up and then down, but it's not all up then down then all up again. It's just kind of scattered about it. And again, if we did this for a super large data set, you would see less indication of this pattern. It'd just be kind of random, static above the x and y, the x-axis rather. So good model, good model, right? And the thing is it just has a much better ability to make predictions. If I was looking at my linear model, just look at the difference in this. If I was to plug in 300 for my linear model, it would be predicting 1,000, okay? But 300 for my exponential model is predicting somewhere around, if I click this, does it tell me these? Yeah, for 300, it's predicting about 500, right? For 300, it's saying 500 versus up here on this model, for 300, it's saying 1,000. So the exponential model does a much better job of making predictions of the growth in this particular situation. So great fun using Desmos. I hope you enjoy this as much as I do. I really enjoy using this product. I think it's fun to use, and it gives me a lot of quick insights into what's happening with the data. And I still like my TI calculator on the go, but I just think it's less tedious to use Desmos, and I just like the look of these graphs better. So anyways, let's move on to, well, that's it. That's it for this problem. Thanks for watching.